Welcome to Sleepless Philosophers, where deep ideas meet restful nights. If you enjoy these journeys through philosophy, please like and subscribe and turn on notifications for daily uploads. To support the channel, consider leaving a super thanks. Any amount helps us continue creating content. You can also become a member to request video topics. We're not monetized, so your support truly makes the difference. Now let the philosophy begin. The EPR paradox, when particles know what their partners are doing. Two particles are created together in a quantum process, perhaps two photons emitted from a single atom, or two electrons produced in a pair, and these particles fly apart in opposite directions, travelling far from each other, perhaps to opposite ends of a laboratory, or even to different planets. And quantum mechanics predicts that these particles remain connected, entangled, in a way that defies classical intuition, because measuring a property of one particle instantly affects the other particle, no matter how far apart they are, and the measurement outcomes are correlated in ways that cannot be explained by assuming each particle carried definite properties from the beginning. And this is the EPR paradox, named after Einstein, Podolsky, and Rosen, who presented it in 1935 as an argument that quantum mechanics is incomplete, that there must be hidden variables, additional information not captured by the quantum wave function that determines the outcomes of measurements and explains the correlations without requiring instantaneous action at a distance. Imagine the scenario more concretely. Two particles are entangled such that they have opposite spins. If one is measured to have spin up, then the other will definitely be measured to have spin down, and vice versa. And this correlation is perfect. 100% whenever both particles are measured along the same axis. And before measurement, quantum mechanics describes each particle as being in a superposition of spin up and spin down, neither definite. And the two particles together are described by an entangled state that cannot be factored into separate descriptions of each particle. The state is inherently joint. And when one particle is measured and found to be spin up, the other particle's state immediately becomes spin down, even if the two particles are light years apart. And this instantaneous correlation troubled Einstein, who called it spooky action at a distance, and argued that it violated the principle of locality, the idea that physical influences cannot travel faster than light, that distant events cannot have immediate effects. Einstein, Podolsky, and Rosen proposed that quantum mechanics is incomplete, that each particle must carry hidden information, hidden variables that determine what the measurement outcomes will be. And these hidden variables are fixed at the moment the particles are created. And so when the particles are measured later, the outcomes are determined by these pre-existing properties, not by any instantaneous influence. And the correlation between the particles is explained by the fact that they started with correlated hidden variables, like two coins that were both set to heads when they left your hand and remain heads as they fly through the air. And when you look at them later, you find them both showing heads. And this correlation does not require any spooky action, just common initial conditions. And EPR argued that quantum mechanics, which does not include these hidden variables, gives an incomplete description of reality. For decades, the EPR argument was a philosophical debate, a question about interpretation and the nature of quantum mechanics. But in 1964, physicist John Bell proved a theorem that transformed the debate into an experimental question. Bell showed that any theory based on local hidden variables, any theory where measurement outcomes are determined by pre-existing properties and where influences travel at or below the speed of light, must satisfy certain mathematical inequalities, now called Bell inequalities, and these inequalities place limits on how strongly the measurement outcomes of two distant particles can be correlated. And Bell showed that quantum mechanics predicts correlations that violate these inequalities, that quantum correlations are stronger than any local hidden variable theory can produce. And so by performing experiments and measuring the correlations, one can test whether nature obeys the Bell inequalities, and if the inequalities are violated, then local hidden variables are ruled out, and quantum mechanics, with its spooky action at a distance, is vindicated. Experiments have been performed many times with increasing sophistication and precision, closing various loopholes, and the results consistently show violations of Bell inequalities, strong correlations that match quantum mechanical predictions, and rule out local hidden variable theories. And so nature does not obey locality in the way Einstein wanted. The particles really are entangled, and measuring one really does instantaneously affect the other. And this is now an established experimental fact, one of the most thoroughly tested predictions in physics, and the EPR paradox has been resolved in favour of quantum mechanics against Einstein's intuitions, though the philosophical implications remain deeply puzzling. The paradox forces a choice between giving up locality or giving up realism, the idea that physical properties have definite values independent of measurement, and most interpretations of quantum mechanics give up realism, accepting that particles do not have definite spin values until measured, that the spin only becomes definite through the act of measurement, and the entanglement means that the two particles are not independent. They form a single quantum system even when separated by vast distances, and measuring one particle provides information about the system as a whole, and this information is reflected in the state of the other particle. But this does not allow faster-than-light communication, because the measurement outcomes are random. Neither particle can control what value it will be measured to have, and so no message can be sent. Only correlations can be observed after the fact by comparing measurement records. Some interpretations of quantum mechanics, like Bohmian mechanics, preserve realism by giving up locality, introducing non-local hidden variables that allow instantaneous influences, pilot waves that guide particles in ways that depend on the entire configuration of the universe. And these theories reproduce the predictions of quantum mechanics and are empirically equivalent, but they are non-local. They violate Einstein's principle that influences cannot propagate faster than light. And most physicists find this cost too high, prefer to accept that realism must be given up, that particles do not have definite properties until measured. Visualize the two entangled particles flying apart, one heading left and one heading right, and they are described by a single wave function, an entangled state that says, if left is up, then right is down, and if left is down, then right is up, but neither is definite until measured. And now imagine measuring the left particle and finding it spin up, and at that instant, even though the right particle is far away, its state changes. It becomes definitely spin down, and if someone measures the right particle immediately after, they will definitely find spin down. And this correlation holds no matter how far apart the particles are, no matter how quickly the measurements are performed, as long as they are performed along the same axis. And this instantaneous correlation cannot be explained by assuming the particles carry definite spins from the beginning. Bell's theorem proves that, and so the correlation is genuinely quantum, genuinely non-local, genuinely spooky. And yet it does not allow signaling, does not allow information to be sent faster than light, because the outcomes are random and cannot be controlled. The EPR paradox stands as one of the deepest puzzles in quantum mechanics, a paradox that led to Bell's theorem, to decades of experimental tests, to the confirmation of quantum non-locality, and to ongoing debates about what quantum mechanics means, about whether reality is fundamentally non-local, about whether measurement is a special process or an ordinary interaction, about whether consciousness plays a role, about whether the universe splits into branches or whether hidden variables exist beyond our current theories, and none of these questions has a settled answer. Different physicists and philosophers hold different views, and the EPR paradox remains a touchstone, a thought experiment that crystallizes the central mysteries of quantum theory. And Einstein's discomfort with spooky action at a distance, his belief that quantum mechanics must be incomplete, has been answered by experiment. Nature really is spooky, particles really are entangled, measurements really do have instantaneous non-local effects. And this is not a failure of the theory, but a feature of reality, a feature that defies classical intuition and forces us to accept that the quantum world operates according to rules that seem impossible, that violate locality, that create correlations stronger than any classical mechanism can produce. And the paradox endures, not as an unsolved problem, but as a solved problem with an unsettling answer. And the particles fly apart, entangled forever, connected by invisible quantum threads, and measuring one affects the other instantly, across any distance, and the universe is non-local. And the EPR paradox, intended to show that quantum mechanics is incomplete, instead revealed that nature is stranger than Einstein imagined. The fixity of the past, why yesterday traps today. A philosopher asserts a principle that seems undeniable, seems like one of the most obvious truths about time, and the principle is that the past is fixed, is unchangeable, is beyond our power to affect, and what has happened, cannot be made not to have happened, and no one can change the past, can reach back through time to alter what occurred, and this fixity of the past seems like a fundamental constraint on agency, seems to limit what we can do, and yet this apparently obvious principle creates puzzles when combined with other beliefs about causation and freedom. Because if the past is fixed, and if determinism is true, then the present is also fixed, is determined by the past, and if the present is fixed, then our actions are fixed, are not up to us, are not within our control, and the fixity of the past combined with determinism leads to the conclusion that we are not free, that everything we do was already settled by factors beyond our control, and this is the fixity of the past problem, the puzzle about how the unchangeability of the past constrains present freedom, about whether fixity transfers from past to present under determinism, about whether we can have power over facts that are determined by fixed facts. And this problem is closely related to the consequence argument and the transfer principle, and resolves in similar ways with compatibilists denying that fixity transfers and incompatibilists insisting that it does, and the fixity of the past stands as another battleground in the free will debate. Imagine the past as a vast record, every event that has ever occurred inscribed permanently, unchangeably, and this record determines, through the laws of nature, everything that will occur, everything you will do, and the record was written before you were born, was fixed billions of years ago when the universe began, and you came into existence within a universe whose future was already determined by its past, and nothing you can do can change that record, can alter what has already happened. And so nothing you can do can alter what will happen, because what will happen is fixed by what has happened, and the fixity of the past extends forward through deterministic causation to create fixity of the future. And if the future is fixed, then freedom is impossible. Then your actions are not up to you, are not within your power, are settled independently of your will. And this reasoning seems compelling, seems to show that determinism plus fixity of past equals no freedom. The fixity of the past can be formulated as a principle. For any fact about the past, no one has power over whether that fact obtained. No one can make it the case that the past was different from how it actually was, and this principle is sometimes called the necessity of the past. Though necessity is a confusing term here because the past is not logically necessary, is not necessary in all possible worlds, but is only fixed in the sense that we cannot change it, cannot affect it retroactively, and the past is settled, is beyond our control, and this settledness seems to spread forward under determinism, seems to make the present also settled, also beyond our control, and freedom disappears, is eliminated by the fixity of the past combined with deterministic causation. Visualize time as a line. The past extends behind, fixed and unchangeable, and the present is the moving point, and the future extends ahead. And if determinism is true, then the future is just as determined as the past is settled by past plus laws. and the only difference between past and future is epistemic. We know the past and do not know the future, but metaphysically they are equivalent, both determined, both fixed, and if we lack power over the past, then we also lack power over the future, because the future is determined by the past, and power does not extend across determination. And so the fixity of the past proves that determinism eliminates freedom. Compatibilists respond to fixity arguments in various ways. One response distinguishes between two kinds of fixity: what is fixed in the sense of being unchangeable retroactively, and what is fixed in the sense of being determined, and argues that while the past is fixed in the first sense, we have no power to go back and change it. The present is not fixed in the first sense, is not in the past, and our current actions determine what the present is. And so we have power over the present, even though we lack power over the past. And the two kinds of fixity are different. And the fixity of the past does not transfer to the present in the way incompatibilists claim. Another compatibilist response appeals to counterfactual power, argues that even though the past is fixed, we have the power such that if we had chosen differently, then the past would have been different. And this counterfactual power is sufficient for freedom, is what matters for responsibility, and the fixity of the past is compatible with our having counterfactual power over the present. And so determinism does not eliminate freedom, and the fixity of the past does not transfer to the present in any sense that threatens freedom. A third compatibilist response accepts that the past is fixed but denies that determinism makes the present fixed in any problematic sense, argues that being determined by the past is not the same as being beyond our control, that our choices are part of the causal chain from past to present, are among the factors that determine what happens, and having our choices be determining factors is what control consists in, is what makes actions up to us. And the fixity of the past is irrelevant, because what matters is not whether the past could have been different, but whether our current choices make a difference. And they do. They determine outcomes. And this is sufficient for freedom. Incompatibilists reject these compatibilist responses, argue that they involve verbal tricks, equivocations on power and control that obscure the real issue. And the real issue is that if the past is fixed and determines the present, then the present is also fixed, is not genuinely open, is not within our control in any sense that matters for responsibility, and compatibilist power is not real power, is a redefinition designed to make freedom compatible with determinism, and the fixity of the past, properly understood, shows that determinism eliminates genuine freedom, eliminates the kind of control required for moral responsibility. The fixity of the past also raises questions about time travel, about whether it is possible to change the past, and most philosophers accept that backward causation is impossible, that we cannot travel back and alter what occurred, because this would create paradoxes, would make it possible for you to prevent your own birth by killing your grandfather before your parents met. And such paradoxes show that the past must be fixed, must be immune to retroactive alteration. But some philosophers argue that time travel is possible as long as it is consistent, as long as any effects you have in the past are already part of the past, as it actually occurred, and this allows time travel without paradox, but requires giving up the idea that you could change the past, could make it different. And this reinforces the fixity of the past, shows that even time travel does not give power over the past. The past sits behind us, vast and unchangeable, every event recorded, every cause set in motion, and the causal chains extend from past to present, determine what is happening now, determine what you're doing, and the fixity of the past. The unchangeability of what has happened seems to make your present action also unchangeable, also fixed, also beyond your control, because if the past could not have been different, and if the past determines the present, then the present could not have been different, and you could not have done otherwise, and freedom is lost, is eliminated by the combination of fixity and determinism. and the fixity of the past remains a central problem for compatibilism, remains a challenge to explain how we can be free if our actions are determined by a past we cannot change. And the answers compatibilists offer remain controversial, remain rejected by incompatibilists who insist that fixity transfers, that unchangeability spreads from past to present under determinism, and the fixity of the past endures as a fundamental constraint on agency, a feature of time that shapes what we can and cannot do, and whether this feature eliminates freedom or merely defines its boundaries remains one of the central questions in philosophy of free will. The garden of forking paths where every choice splits reality. A writer imagines time as a garden of forking paths, a labyrinth where each decision creates a branching, where reality splits into multiple futures, one for each possible choice, and this image captures something deep about how we experience decision-making. We stand at forks, at moments where multiple paths lie ahead, and we choose which path to take. And unchosen paths remain as real possibilities, as roads not taken, and this multiplicity of possibilities, this forking structure of time, seems essential to freedom, seems to be what makes choice meaningful, because choosing requires alternatives, requires that other options be genuinely possible, genuinely available, and yet physics tells a different story, tells us that reality does not actually fork, that there is one actual future, one path that will be taken, and the other paths are mere possibilities, unreal, never actualized, and this creates tension between the subjective experience of forking paths and the objective reality of a single actual future. And this tension is what the garden of forking paths represents. The conflict between the branching structure we experience and the linear structure physics describes. And resolving this tension requires understanding what possibilities are, whether they are real or merely epistemic, whether the garden of forking paths is a feature of reality or only of our ignorance. And this is the garden of forking paths problem, the question of how to reconcile freedom, which seems to require genuine alternatives, with determinism, which says only one future is possible. Imagine standing at a fork, two paths before you, and you must choose which to take. And both paths seem open, seem available, seem like real options, and you deliberate, consider reasons for each path, weigh consequences, and make a decision. And as you walk down the chosen path, you look back at the fork and see the unchosen path receding behind you. And that path represents what could have been, what might have happened. And this counterfactual, this alternative possibility seems essential to the meaning of your choice. Because if the unchosen path was never really possible, if you were always going to choose as you did, then the deliberation seems pointless, seems like theatre, and the choice seems less significant, less truly yours. And yet determinism says the unchosen path was never really possible, was never going to be actualized, was only possible in your ignorance of which path you would take. And the garden of forking paths is a map of ignorance, not a map of reality, and the paths that seem to fork actually do not actually collapse to a single trajectory determined by past and laws. The garden of forking paths is a metaphor from Jorge Luis Borges, from his story about a novel that represents time as forking, where every possible future exists in parallel, where the protagonist makes different choices in different branches, and all branches are real, all a part of the same story. And Borges uses this to explore ideas about time and possibility and narrative, and philosophers have adopted the metaphor to represent the libertarian view of free will. The view that when we make choices, reality genuinely branches, multiple futures exist, and our choice determines which branch becomes actual. And this contrasts with the compatibilist view, where the garden does not actually fork, where only one future was ever possible. And deliberation is about discovering which future is actual, rather than creating which future is actual. Visualize the metaphor more precisely. At each moment of choice, the timeline splits, one branch for voting for candidate A and another for voting for candidate B, and both branches are real. Both exist as genuine possibilities, and the agent's choice makes one branch actual and the other merely counterfactual. And if this picture is correct, then free will is preserved because genuine alternatives existed. But if this picture is wrong, if only one branch is real and the other is merely imagined, then free will is threatened. Then the agent never really had alternatives, never really chose between real possibilities, only discovered which possibility was actual all along. The Garden of Forking Paths connects to debates about the metaphysics of time, about whether the future is open or closed, whether future contingents have truth values, whether statements about what will happen tomorrow are true or false now, or are neither true nor false until tomorrow arrives. And open future theorists say the future is genuinely open, genuinely indeterminate. The garden genuinely forks, and multiple futures are possible, and closed future theorists say the future is already determined, already fixed. Only one future is possible, and the garden does not really fork, only appears to fork from our limited perspective. One response to the Garden of Forking Paths embraces the branching metaphor, adopts the growing block theory of time, where the past and present are real and the future is not yet real, is open, is genuinely undetermined. And as time progresses, the future becomes present and then past, and the timeline grows. And at moments of free choice, the timeline branches, multiple futures become actualized, and libertarian free will is preserved. But critics argue that this picture is inconsistent with physics, with relativity, which says that simultaneity is relative, that there is no objective present moment, and the growing block theory cannot be reconciled with relativity, and so the Garden of Forking Paths cannot be real, is only a convenient fiction. Another response denies the branching, accepts that only one future is real, and argues that free will does not require genuine branching, does not require that unchosen alternatives be real, but only requires that the agent's choice be the determining factor in which future is actualized. And as long as the agent's deliberation and decision play a causal role, as long as the action flows from the agent's own reasons and desires, the agent is free, and the Garden of Forking Paths is an epistemic representation, a map of what might happen from the agent's perspective, but not a metaphysical reality. And this compatibilist response preserves free will without requiring genuine metaphysical branching. A third response appeals to the many worlds interpretation of quantum mechanics, where every quantum measurement causes the universe to split into multiple branches, one for each possible outcome, and all branches are real. All exist in a vast multiverse, and human choices might involve quantum processes, might cause branching at the quantum level. And so the Garden of Forking Paths is literally real, is part of the structure of quantum reality, and every choice you make creates multiple versions of you in different branches, and free will is preserved because genuine branching occurs. Though this response raises questions about which branch is you, about personal identity across branches, about whether it matters that other branches exist if you can never observe them or interact with them. The Garden of Forking Paths also appears in discussions of regret and counterfactuals, because when we regret choices, we imagine the path not taken, imagine how things would have been if we had chosen differently. And this imagining treats the unchosen path as a real possibility, as something that could have happened. And the question is whether this treatment is accurate, whether the unchosen path was genuinely possible, or was only possible in our imagination, only possible relative to our ignorance. And if only imaginary, then regret is irrational, is lamenting something that could never have been. And if genuinely possible, then regret is rational, is lamenting a real alternative that was available but not chosen. The writer walks through the garden, sees the paths forking ahead, sees the labyrinth of possibilities, and each fork represents a choice, a moment where the future is open, where alternatives exist, and the writer chooses again and again, and each choice closes off paths, eliminates possibilities, and the unchosen paths remain behind, fading into counterfactual space. And whether these unchosen paths are real, whether they exist somewhere in quantum multiverse or only in imagination, determines whether the garden of forking paths is a true picture of reality or only a useful metaphor. And the question remains open, remains disputed, and the garden remains, branching or not branching, forking or merely appearing to fork. And we walk through it, choosing paths, deliberating at forks, and whether the alternatives are real or illusory. Whether the garden genuinely branches or only seems to, shapes how we understand freedom, how we interpret choice, and whether determinism eliminates the garden or merely reveals that it never really forked. And the metaphor endures, beautiful and problematic, a representation of how choice feels from the inside, even if not how choice is from the outside. And the garden of forking paths remains a permanent fixture in discussions of free will, a vivid image that captures the experience of agency, even as physics and metaphysics question whether the image corresponds to reality. The hedonistic paradox: why chasing happiness makes you miserable. Happiness is what everyone wants, pleasure and contentment and satisfaction, the good feelings that make life worth living, and hedonism is the philosophy that says pleasure is the highest good, that we should pursue happiness and avoid pain, that maximizing pleasant experiences is the rational goal of life. And this seems straightforward, seems like obvious common sense. Who would argue against seeking happiness? And yet a strange paradox emerges. The more directly you pursue happiness, the more it eludes you. The more you focus on your own pleasure, the less pleasure you actually experience. And this is the hedonistic paradox, also called the paradox of hedonism, first articulated clearly by philosopher Henry Sidgwick in the 19th century and echoed by thinkers from ancient Stoics to modern psychologists. The observation that happiness cannot be obtained by pursuing it directly, that it comes instead as a byproduct of other activities, of pursuing goals and relationships and meaningful projects that are not themselves about happiness. And the paradox reveals something deep about human psychology, about the nature of satisfaction, about how conscious desire and self-awareness can undermine the very experiences they seek. Imagine someone who decides to maximize their happiness, who reads books about pleasure, who measures their mood constantly, who makes decisions based purely on what will bring the most immediate satisfaction, choosing activities because they are supposed to be fun, spending time with people because those people are supposed to make them happy, eating foods because they are supposed to taste good. And this person is completely focused on their own hedonic state, monitoring their feelings, evaluating whether each moment is bringing sufficient pleasure. And paradoxically, this constant self-monitoring and evaluation interferes with enjoyment, prevents immersion, creates anxiety about whether happiness is being achieved. And the person finds that despite optimizing for pleasure, they feel less satisfied than when they were not trying so hard, when they were engaged in activities for their own sake, rather than as means to happiness. The paradox operates through several mechanisms. One is self-consciousness. When you're focused on your own experience, watching yourself to see if you're happy, you cannot be fully present in the moment, cannot lose yourself in an activity. And this divided attention, this standing outside yourself observing, prevents the flow states and deep engagement that actually produce lasting satisfaction. Like trying to fall asleep by focusing intently on falling asleep, the effort itself becomes an obstacle, creates tension that prevents the desired state. And the same applies to pleasure. The monitoring prevents the experience. Another mechanism is adaptation and expectation. When happiness becomes the explicit goal, expectations rise. And when expectations rise, satisfaction falls. Because satisfaction depends not just on absolute pleasure, but on the gap between expectation and reality. And someone who expects to be happy all the time, who demands high levels of pleasure, will be disappointed by ordinary experiences that might have been satisfying without the inflated expectations. And so the pursuit of happiness creates conditions that make happiness harder to achieve. A third mechanism involves meaning and purpose, because the activities that produce the deepest and most lasting satisfaction are often those pursued for reasons other than pleasure, work that feels meaningful, relationships built on genuine care rather than instrumental benefit, creative projects undertaken for their own sake, struggles and challenges that are difficult but worthwhile. And these activities produce satisfaction precisely because they are not aimed at happiness, because they involve commitment to something beyond the self. And when happiness becomes the goal, these activities lose their meaning, become merely instruments for feeling good, and the meaning drains away, and with it the satisfaction. Visualize a person at a party who is there solely to have a good time, who evaluates every conversation by whether it is making them happy, who moves from group to group seeking the optimal pleasure, and compare this to someone who is genuinely interested in the people they meet, who engages with conversations because the topics matter, who is fully present rather than constantly evaluating. And the second person, paradoxically, has a better time, experiences more pleasure, not because they were aiming for it, but because they were aiming at something else, at connection, at understanding, at engagement. The ancient Stoics recognized this paradox, argued that pursuing pleasure directly leads to disappointment and suffering, that the wise person should instead focus on virtue, on living according to nature, on accepting what happens with equanimity. And happiness emerges as a consequence of wisdom and virtue rather than as a direct goal. And the Stoics were hedonism's critics, argued that pleasure is too unreliable, too fleeting, too dependent on external circumstances to be a good foundation for life. And the hedonistic paradox supports this critique, shows that even on hedonism's own terms, even accepting that pleasure is what we ultimately want, the direct pursuit of pleasure is self-defeating. John Stuart Mill, himself a utilitarian who believed in maximizing happiness, acknowledged the paradox and distinguished between higher and lower pleasures, suggesting that the deepest satisfaction comes from intellectual and moral activities rather than from sensory gratification, and that a life spent chasing immediate sensory pleasure is less happy than a life devoted to knowledge, virtue, and meaningful relationships, even if the latter involves more difficulty and occasional pain. Modern psychology has confirmed the hedonistic paradox. Through empirical research, studies show that people who explicitly prioritize happiness report lower life satisfaction than those who prioritize other values like meaning, relationships, or personal growth, that people who pursue pleasure for its own sake experience more depression and anxiety, that flow states and peak experiences occur when people are absorbed in challenging activities, not when they are relaxing or seeking pleasure directly, and that the happiest societies are not those where people pursue individual happiness most intensely, but those where people are embedded in strong communities and engaged in collective projects that transcend individual pleasure. The paradox also appears in consumer culture, where advertising promises happiness through products, through purchases, through experiences designed to deliver pleasure. And people chase these promises, buying things they do not need, pursuing lifestyles marketed as paths to satisfaction, and finding that the purchases bring momentary pleasure followed by adaptation and renewed dissatisfaction. The hedonic treadmill, where each purchase raises expectations and the baseline returns to where it was, and the pursuit of happiness through consumption becomes a trap, a cycle that produces more desire than satisfaction, more anxiety than contentment. And the paradox reveals that happiness is not a commodity, cannot be bought or manufactured, cannot be achieved by optimizing choices, but emerges from patterns of life, from relationships and meaning and engagement with the world. Some philosophers have argued that the hedonistic paradox refutes hedonism entirely, shows that pleasure cannot be the ultimate good because it cannot be achieved by aiming at it. That any theory of value must accommodate the fact that some goods are essentially byproducts, cannot be attained through direct pursuit, and this points toward alternative theories like virtue ethics, where the goal is to develop character traits and live well, rather than to maximize pleasant experiences, or like existentialism, where the goal is authenticity and creating meaning rather than achieving happiness. Others argue that the paradox does not refute hedonism, but only shows that indirect strategies are required, that sophisticated hedonists should not focus on their own happiness, but should pursue other goals, knowing that these pursuits will produce happiness as a side effect. And this move preserves hedonism as a theory of value, while acknowledging the psychological reality that direct pursuit fails. The person sits alone, measuring their happiness on a scale from 1 to 10, recording their mood, planning activities to maximize pleasure, and the numbers are disappointing, the satisfaction elusive, and slowly the realization dawns that the pursuit itself is the problem, that happiness was never meant to be a target but a byproduct, that the good life is not found by seeking it but by living it, by engaging with the world, by caring about things beyond oneself, by accepting that some suffering is inevitable and some pleasures are fleeting, and that meaning is more important than happiness anyway. And the paradox resolves not by discovering a technique for achieving happiness, but by abandoning happiness as the goal, by recognizing that the best moments come unbidden, arrive when we are focused elsewhere, and that the life worth living is not the one that feels best moment to moment, but the one that matters, that connects, that contributes, and the hedonistic paradox remains. Not as a puzzle to solve, but as a truth to accept, a reminder that we are not built for pure pleasure seeking, that our psychology is more complex than simple hedonism allows, and that the path to satisfaction runs through meaning and connection and purpose, rather than through the direct pursuit of happiness itself. The Grelling-Nelson paradox. Words can describe themselves or they cannot, and this seemingly innocent observation becomes a doorway into paradox when Kurt Grelling and Leonard Nelson posed a question in 1908 that has troubled philosophers of language ever since. Some words are autological, meaning they possess the property they describe. The word short is short. The word English is English. The word polysyllabic is polysyllabic. And these words refer to themselves in a way that feels consistent and unproblematic. Other words are heterological, meaning they do not possess the property they describe. The word long is not long. The word German is not German. The word monosyllabic is not monosyllabic. And again, this seems straightforward. A simple division between words that apply to themselves and words that do not. The paradox emerges when the question is asked, is the word heterological? Itself heterological. And the mind stumbles immediately into the same kind of self-referential trap that haunts the liar paradox and Russell's paradox. If heterological is heterological, then it does not describe itself, which means it must be autological. But if it is autological, then it does describe itself, which means it must be heterological. And the loop spins without resolution, each answer immediately negating itself. This is not merely a trick of language, but a genuine problem for anyone attempting to build a theory of meaning or reference, because it suggests that not all predicates can be safely applied to themselves, that self-reference introduces instability into linguistic systems. Some philosophers argue that heterological is simply a defective predicate, a word that fails to have a coherent meaning because its definition leads to contradiction. Much like dividing by zero produces an undefined result in mathematics. Others suggest that the paradox reveals the difference between the use of a word and its mention, that when we ask whether heterological is heterological, we are confusing the word as an object with the word as a concept, and this confusion generates the paradox. Alfred Tarski proposed that language operates on different levels, with a meta-language used to talk about an object language, and that paradoxes like Grelling-Nelson arise when these levels are improperly mixed, when language tries to fully describe itself from within rather than from a higher vantage point. The paradox also connects to broader issues in semantics and the philosophy of language, questions about how words acquire meaning, whether meaning is fixed or context-dependent, and what it means for a word to refer to itself. If even simple adjectives can generate contradictions through self-reference, then the project of creating a complete and consistent theory of language may be impossible, or at least far more complicated than it first appears. The Grelling-Nelson paradox lingers at the edges of linguistic theory, a small question with large implications, a reminder that words are not just labels for things, but slippery tools that can twist back on themselves in unexpected ways, and that the quest to understand meaning must navigate carefully around the traps that self-reference sets. The growing argument, objects change size over time. A child grows into an adult, a sapling becomes a tree, a pebble is worn smooth by erosion, and yet we say these are the same entities, the same person, the same tree, the same stone. But if size and shape change, can identity truly remain? And this is the growing argument, sometimes called the growing block paradox, or the problem of material constitution. A puzzle about how objects can gain or lose parts while remaining numerically identical to themselves. Consider a statue made of clay, and a sculptor adds more clay to it, making it larger, and then removes some clay, making it smaller. And at each moment, the statue is made of different material, occupying a different volume, and yet we call it the same statue throughout the process. But if the statue is identical to the lump of clay that constitutes it, then the statue and the clay should share all their properties. Yet the statue has properties the clay does not. The statue has aesthetic value. The statue was created at a certain time. The statue could survive minor alterations, while the clay, as a mere lump, has none of these properties. And so the statue and the clay cannot be identical, even though they occupy the same space and are made of the same material. The paradox deepens when we consider the career of the clay. The lump existed before the statue was formed, and will exist after the statue is destroyed, and so the lump and the statue have different temporal boundaries. They begin and end at different times, and if they are not identical, then there must be two objects occupying the same space at the same time, the lump and the statue. And this seems strange, an unnecessary multiplication of entities. Some philosophers embrace this conclusion, arguing that the world contains far more objects than we ordinarily recognize, that every statue is accompanied by a lump, every organism by a mass of cells, every table by a quantity of wood, and that identity is highly context-sensitive, determined by how we carve up the world conceptually rather than by objective metaphysical facts. Others reject this view, arguing that the statue and the lump are the same object considered under different descriptions, that the properties that seem different are not intrinsic properties but extrinsic or relational ones, that being a statue is a matter of how the lump is shaped and how it is regarded rather than being a separate object. The growing argument also applies to living organisms. Because a person gains and loses atoms constantly, the body grows from infancy to adulthood, shrinks in old age, yet personal identity persists. And the question arises whether the person is identical to the collection of matter that makes up their body at any given moment. And if not, then what are they? And if so, then how can they survive the replacement of that matter over time? Mereology, the study of parts and wholes, offers various theories to address these puzzles. Some argue that objects are identical if they share all the same parts at the same time, while others allow for gradual replacement, saying that identity can be maintained as long as the changes are continuous and not too drastic. And still others embrace temporal parts, arguing that objects are four-dimensional, with different temporal slices, and that the question of identity over time is really a question of whether those slices are connected in the right way. The growing argument forces confrontation with the question of what objects are, whether they are material lumps, patterns, processes, or conventional designations, whether identity is absolute or relative, whether the world contains discrete, persistent entities or only a flux of matter temporarily arranged in stable configurations, and whether our language and concepts, which treat objects as enduring individuals, accurately reflect the structure of reality or impose a simplifying grid on something far more fluid and complex. The paradox remains unresolved, a source of ongoing debate in metaphysics, and it reminds us that growth and change, the most ordinary features of existence, conceal profound mysteries about identity, persistence, and the nature of the things that populate our world. The hard problem of consciousness: why brain activity does not explain experience. A neuroscientist maps every neuron in the visual cortex, traces every connection, measures every firing pattern, understands completely the physical processes that occur when someone sees the color red, knows which wavelengths of light activate which photoreceptors, which signals travel along which pathways, which brain regions respond, and the scientist can predict with perfect accuracy when someone will report seeing red, can manipulate brain states to produce the experience, has complete knowledge of the physical mechanisms. And yet philosopher David Chalmers asks a question that this knowledge does not answer. Why is there something it is like to see red? Why does the physical processing produce a subjective experience, a quale, a feeling of redness that exists from the inside, from the first-person perspective? And this question is the hard problem of consciousness, the problem of explaining why and how physical processes give rise to subjective experience, to phenomenal consciousness, to the felt quality of mental states. And Chalmers distinguishes this from the easy problems, which are merely difficult scientific questions about how the brain processes information, how it integrates data, how it produces behavior. And while these easy problems are challenging, they are tractable, are problems science can solve through normal methods. But the hard problem is different, is a question of a different kind. Asks not how consciousness functions, but why it exists at all. Why there is subjective experience accompanying physical processes rather than those processes occurring without any inner experience, without anything it is like to undergo them. Imagine a zombie, a philosophical zombie, a creature that is physically identical to a human being, molecule for molecule, neuron for neuron, that behaves exactly like a human, says the same things, acts the same ways, but has no inner experience, no consciousness, is dark inside. And Chalmers argues that such a zombie is conceivable, is logically possible. And if zombies are possible, then consciousness is not reducible to physical processes, because the zombie has all the physical processes but lacks consciousness. And so consciousness must be something additional, something over and above the physical. And this is why the hard problem is hard, because it seems to require explaining how something non-physical, something subjective, emerges from something physical, something objective. And no amount of knowledge about brain function, about neural mechanisms, about information processing, seems to bridge this gap, seems to explain why there is something it is like rather than nothing. Visualize the explanatory gap. On one side is all the physical information, all the facts about brain states and neural firing and chemical processes, and on the other side is subjective experience, the redness of red, the painfulness of pain, the taste of coffee, and the gap between these two sides seems unbridgeable. Seems like knowledge of one does not give knowledge of the other. And no matter how much we learn about brains, we do not seem to get closer to explaining why brains produce consciousness, why certain physical systems have inner lives. And this gap is what makes the hard problem hard, what makes consciousness seem mysterious, What makes it resist scientific explanation? The hard problem has generated multiple responses: materialists who deny that there is a hard problem, who argue that consciousness is reducible to physical processes, that once we fully understand the brain, we will understand consciousness, that the appearance of a gap is due to our current ignorance, and dualists who accept the hard problem and argue that consciousness is non-physical, is a separate substance or property that exists alongside the physical, and Mysterians who accept the hard problem but argue that it is unsolvable, that human cognitive capacities are limited, that we may never understand how consciousness arises from physical processes because our minds are not equipped to grasp the answer. One materialist response appeals to functionalism, argues that consciousness is not a separate thing, but is identical to certain functional roles, certain patterns of information processing, and what it is like to see red is just the functional role that seeing red plays in the cognitive system, the way it affects memory and behavior and other mental states. And this functional role can be fully captured physically, can be explained in terms of brain processes, and so there is no explanatory gap, no hard problem, only a conceptual confusion that disappears once we realize that consciousness is function and function is physical. Another materialist response appeals to eliminativism, argues that our ordinary concepts of consciousness are confused, are based on folk psychology that science will replace. And when neuroscience matures, we will abandon talk of subjective experience, we'll recognize that what we called consciousness was really just neural processes misdescribed, and the hard problem will dissolve, because the phenomenon it concerns, subjective experience as we currently conceive it, does not exist, and this radical response rejects the starting point of the hard problem, rejects that there is anything subjective that needs explaining. Dualist responses accept that consciousness is irreducibly subjective, is not reducible to physical processes, and argue for property dualism, where consciousness is a non-physical property that physical systems can have, or substance dualism, where consciousness is a separate mental substance that interacts with the physical body. And these views face the interaction problem, the question of how non-physical consciousness can affect physical processes, how mental causation works, and dualists have proposed various answers, some appealing to fundamental psychophysical laws, others denying that consciousness has causal power, but none has achieved consensus. Mysterian responses associated with Colin McGinn accept that the hard problem is real, but argue that it is unsolvable by humans, that our cognitive architecture is not suited to understanding how consciousness arises from matter. Just as rats cannot understand quantum mechanics, humans cannot understand consciousness. And this is not a failure of science, but a limit of human cognition. And we should accept this limit, recognize that some questions are beyond us, and the hard problem is one of them. The hard problem also connects to the knowledge argument. To Mary, the colour scientist who knows all physical facts about colour but has never seen colour, and when she finally sees red for the first time, she learns something new, learns what red looks like, and this suggests that physical knowledge does not exhaust knowledge about consciousness, that there are facts about subjective experience that are not physical facts, and this supports the view that consciousness is not reducible to physical processes, that the hard problem is real. The neuroscientist continues mapping neurons, continues discovering mechanisms, and the scientific progress is real, is impressive, reveals extraordinary complexity in how brains process information. But the hard problem remains, the question of why this processing feels like anything, why there is an inner light, why we are not zombies, and Chalmers's challenge persists, unsolved, perhaps unsolvable, a permanent limit on scientific explanation, or perhaps a confusion that will dissolve with better understanding. And philosophers and scientists continue to debate, continue to propose theories, continue to argue about whether consciousness is physical or non-physical, reducible or irreducible, explicable or mysterious, and the hard problem endures as one of the central problems in philosophy of mind, a problem that touches on the nature of reality, on the relationship between mind and matter, on what we are and what it means to be conscious. And the problem remains hard, stubbornly resistant to solution, a gap that knowledge does not seem to close, an explanatory challenge that persists despite centuries of reflection and decades of neuroscience, and consciousness continues to feel mysterious, continues to seem like something that physics cannot capture. And the hard problem stands as a monument to this mystery, a permanent reminder that subjective experience, the felt quality of mental life, resists reduction to objective physical processes. And whether this resistance reflects a genuine metaphysical divide or merely our current conceptual limitations remains one of philosophy's deepest and most difficult questions. The infinite shadow paradox, when your shadow could cover the universe. Imagine standing in a bright room with a light source behind you, casting your shadow on the wall in front of you, and the shadow is roughly your size, perhaps slightly larger, depending on the distance between you and the light. And now imagine moving the light farther and farther away, keeping it directly behind you. And as the light moves back, your shadow grows larger, stretching taller and wider on the wall, because the light rays diverge more gradually, creating a bigger shadow. And if you continue this process, moving the light farther and farther away, your shadow continues to grow. And now the question emerges, what happens if the light source is infinitely far away? If the light comes from an infinite distance, does your shadow become infinitely large? Does it stretch across the entire wall, the entire room, the entire planet, the entire universe? And if so, what does this mean? How can your finite body cast an infinite shadow? And this is the infinite shadow paradox, a thought experiment that reveals tensions between geometry, infinity, and the behavior of light. Consider the geometry more carefully. When the light is close behind you, the light rays that graze the top of your head and the light rays that graze your feet diverge at a large angle, creating a shadow that is only slightly larger than your body. But as the light moves farther away, the angle between these rays decreases. The rays become more nearly parallel, and the shadow grows proportionally. And in the limiting case where the light is infinitely far away, the rays become perfectly parallel, and the shadow, if it still makes sense to talk about a shadow, is no longer a finite shape on a surface, but an infinite column of darkness extending forever in the direction away from the light. And your body blocks a certain solid angle of light, a cone of rays, and when the light is infinitely far away, this cone becomes a cylinder, extending infinitely. And so, in some sense, your shadow has become infinite. It covers an infinite region of space. But there is something strange about this conclusion, because in reality, when light comes from very far away, like sunlight which travels from the sun 93 million miles distant, shadows are sharp and well-defined, not infinite. And the reason is that even though the sun is very far away, it is not infinitely far. And more importantly, the sun is not a point source. It is an extended object, a sphere, and light comes from every point on the sun's surface. And these different light sources create slightly different shadows that overlap. And the overlapping softens the edges and prevents the shadow from extending infinitely. And so the paradox relies on an idealization, a perfectly point-like light source at infinite distance. And this idealization does not correspond to physical reality. And so the infinite shadow is a feature of the idealized model rather than a genuine physical phenomenon. Another way to resolve the paradox is to recognize that the concept of a shadow depends on there being a surface on which the shadow is cast, a wall or a floor or the ground. And if the light is infinitely far away and there is no surface, then there is no shadow in the usual sense. There is a region of space from which light is blocked, but without a surface to project onto. The notion of shadow loses its meaning, and so the infinite shadow is not a shadow at all, but an abstract geometric construction, a cylinder of blocked light extending through space. And whether this deserves to be called a shadow or an infinitely large shadow is a matter of definition rather than a physical fact. The paradox also connects to questions about parallel lines and perspective, because in ordinary experience, parallel lines appear to converge at a vanishing point on the horizon. Train tracks appear to meet in the distance, even though they remain the same distance apart. And this convergence is a feature of perspective, of how our eyes or cameras project three-dimensional space onto two-dimensional images. But in the case of light rays coming from infinity, the rays are truly parallel, not merely appearing parallel, and parallel lines by definition never meet, extend forever without intersecting. And so the shadow, defined as the region blocked by your body from these parallel rays, is a cylinder that extends infinitely. And there is no convergence, no finite boundary. And the paradox is that this seems to make your small body relevant to arbitrarily distant regions of space, seems to give your finite physical presence infinite geometric reach. Some philosophers have used the infinite shadow paradox to argue about the nature of infinity and the limits of physical realizability, suggesting that infinite quantities like infinite distance or infinite extension cannot actually occur in the physical universe, that they are useful mathematical idealizations, but not genuine features of reality. And the paradox supports this view by showing that infinite idealizations lead to strange consequences that do not match experience. And so perhaps infinity is a tool for calculation rather than a description of the actual world. And the paradox is avoided by rejecting the premise that light can come from infinite distance, or that shadows can extend infinitely. Others embrace the paradox as revealing something genuine about geometry and light, accepting that in an idealized geometric setting, with a point source at infinity and parallel rays, shadows do become infinite. And this is not a contradiction, but a feature of how geometry works, and the fact that physical light sources are extended and finite distances are never truly infinite means that the paradox does not apply to real shadows, but it remains a valid thought experiment about what would happen in an idealized limit. And such thought experiments are valuable for understanding the structure of space and the behavior of light, even if they do not correspond to observable phenomena. Visualize yourself standing on an infinite flat plane, with a point of light infinitely far behind you, and the light rays come in perfectly parallel, and your body blocks a cylinder of these rays, and the cylinder extends forward forever. And if there were a wall anywhere in front of you, no matter how far away, your shadow would appear on that wall, and the shadow would be exactly your size, exactly your shape, because the parallel rays preserve size and shape. And so, in this sense, your shadow is not infinitely large, but infinitely long. It is a finite cross-section extended through infinite space. And whether this counts as an infinite shadow or merely an infinitely extended shadow is a question of terminology. But the strangeness remains, the fact that your finite body has infinite geometric influence. The paradox also appears in discussions of cosmology and the nature of the universe, because if the universe is infinite in spatial extent and light travels in straight lines, then in principle, a light source on one side of the universe could cast shadows of objects on the other side, and the time required for light to travel such distances would be infinite. And so the shadow would never actually form, would always be in the process of propagating, and this raises questions about whether infinite distances are meaningful, whether light travelling forever without reaching a destination is different from light that does not exist, and whether geometric constructions that invoke infinity are useful descriptions or merely mathematical artifacts. The shadow stretches forward, grows as the light recedes, and in the limit becomes infinite, a column of darkness extending without end, and you stand there, finite and small, casting a shadow that reaches to infinity. And the paradox asks whether this makes sense, whether infinite shadows are possible, whether geometry allows such things. And the answer depends on what idealizations are accepted, on whether point sources and infinite distances and perfect parallel rays are admitted. And if they are, then the shadow is infinite, and if they are not, then the paradox dissolves. And the paradox remains a teaching tool, an illustration of how infinity changes things, how limits can produce strange results, how geometric reasoning applied to idealized cases can lead to conclusions that violate intuition, and the shadow persists, stretching toward infinity, a monument to the strangeness of geometric idealizations and the care required when reasoning about the infinite. The knowledge argument, what the color scientist learns when she leaves her room. A scientist named Mary spends her entire life in a black and white room, a room devoid of color, where everything is shades of grey. And Mary is a brilliant neuroscientist who specializes in color vision, and she studies color from this colorless room using black and white monitors and books. And she learns everything physical there is to know about color, learns about wavelengths and photoreceptors and neural pathways, learns about opponent processing and color constancy, knows exactly which brain states correspond to which color experiences, can predict with perfect accuracy what someone will report when shown a colored object. And Mary's knowledge of the physical facts about color is complete, exhaustive, includes every fact that physics, chemistry, and neuroscience can provide. And yet Mary has never seen color, has never experienced red or blue or yellow. And then one day, Mary leaves the room, steps outside, and sees a ripe tomato for the first time. And she experiences red. And philosopher Frank Jackson asks, does Mary learn something new? Does she gain new knowledge when she sees red for the first time? And the intuition is yes. She learns what red looks like, learns what it is like to experience red. And this new knowledge is not physical knowledge, because she already had all physical knowledge. And so there are facts about consciousness, facts about subjective experience that are not physical facts. And physicalism is false. And this is the knowledge argument, also called the Mary argument, one of the most influential arguments against physicalism, a challenge to the view that the physical facts exhaust all facts. Imagine Mary's situation, surrounded by books and papers explaining colour in physical terms. She knows that red light has wavelengths around 700 nanometers, knows that it activates long wavelength cones in the retina, knows the neural pathways from retina to visual cortex, knows which patterns of neural firing correspond to red experiences, and she can answer any questioner about the physics and neuroscience of colour, can predict how people will react to colours, what they will say, how their brains will respond. And yet when she sees red for the first time, she says, aha, so that is what red looks like. And this reaction suggests she learned something, gained knowledge she did not have before. And since she already knew all physical facts, the new knowledge must be non-physical, must be knowledge of phenomenal facts, of what experiences are like. And these phenomenal facts are not reducible to physical facts, are additional to them. And so physicalism is incomplete, fails to capture everything about consciousness. The knowledge argument can be formulated as follows. Mary knows all physical facts about colour vision before leaving the room. When Mary leaves the room and sees red, she learns something new. Therefore, there are facts about colour vision that are not physical facts. And this conclusion supports property dualism, supports the view that conscious experiences have phenomenal properties that are not physical properties, that the subjective character of experience is something over and above the objective physical facts. And the argument challenges physicalist theories of mind, challenges the claim that neuroscience can give complete knowledge of consciousness, suggests that first-person subjective experience involves aspects that third-person objective science cannot capture. Visualize the two kinds of knowledge. On one side is Mary's complete physical knowledge, all the objective facts about colour, the facts that can be stated in scientific language, measured by instruments, predicted by theories. And on the other side is phenomenal knowledge, knowledge of what red looks like, knowledge that can only be acquired through experience, through having the experience oneself. And the knowledge argument says these two kinds of knowledge are distinct, that no amount of the first kind can yield the second kind, and this distinctness shows that phenomenal facts are not physical facts, that consciousness has properties that resist physical reduction. Physicalists have developed multiple responses to the knowledge argument. The ability hypothesis argues that what Mary gains when she leaves the room is not new factual knowledge, but new abilities. The ability to recognize red, to imagine red, to remember red. And abilities are not facts, are know-how rather than know that. And so Mary's gain does not show that there are non-physical facts, only that physical knowledge does not automatically confer all abilities. And this response distinguishes knowing facts from having abilities, treats phenomenal knowledge as a kind of skill rather than propositional knowledge. The acquaintance hypothesis argues similarly that Mary gains acquaintance with red, becomes directly related to the experience of red in a way she was not before. But this acquaintance is not knowledge of new facts, it is a new way of knowing old facts, a new mode of presentation of facts she already knew. And so the knowledge argument fails because what Mary gains is not new knowledge, but new acquaintance. An acquaintance with experiences is compatible with physicalism does not show that there are non-physical facts. The old fact, new guise response argues that Mary learns no new fact but learns an old fact in a new way, learns about the physical property of experiencing red by having that experience, whereas before she only knew about it through descriptions and theories. And the same fact, the physical fact about red experiences, can be grasped in different ways, through theoretical knowledge or through direct experience, and Mary's situation involves gaining a new mode of access to old facts, not gaining access to new facts, and so the argument does not refute physicalism. Another response denies the key intuition, argues that Mary does not learn anything new when she leaves the room, that she already knew what red looks like from her complete physical knowledge. That complete physical knowledge includes phenomenal knowledge, and our intuition to the contrary is mistaken, is based on underestimating what complete physical knowledge would include. And if Mary truly knew everything physical about colour, then she would be able to deduce what red looks like, would already have phenomenal knowledge. And so the argument's premise is false. The knowledge argument also raises questions about the relationship between different kinds of knowledge, between theoretical and experiential knowledge, between objective and subjective perspectives, and whether these can be integrated, whether science can accommodate first-person phenomenal facts. And Jackson himself later rejected the knowledge argument, became a physicalist, argued that the knowledge Mary gains is not knowledge of new facts but is compatible with physicalism, though other philosophers continue to defend the argument, continue to insist that Mary's gain shows the incompleteness of physical accounts of consciousness. Mary sits in her black and white room, learning about colour, mastering every physical fact, and then she steps outside, and the world bursts into colour, and she sees red for the first time, and the tomato glows in the sunlight, and her reaction is wonder, is discovery, is the sense of learning something utterly new, and whether this reaction reveals that physicalism is false, that consciousness includes non-physical properties, or whether it merely shows that knowledge comes in different forms, different modes, remains disputed, remains one of the central debates in philosophy of mind, and the knowledge argument persists, powerful and controversial, a challenge to physicalist theories, a defense of the irreducibility of phenomenal consciousness, and a reminder that subjective experience, the what-it-is likeness of mental states, resists capture in purely objective physical terms, and Mary's story continues to be told, to be analysed, to be debated, and the question remains, did she learn something new, something that physical knowledge could not provide? And the answer determines whether consciousness can be fully explained by neuroscience, or whether phenomenal experience involves something more, something that transcends the physical, and the knowledge argument endures as a vivid illustration of the explanatory gap, the gap between physical facts and phenomenal facts, between brain and mind, between what we can know objectively and what we can only know by experience. The manipulation argument, when being programmed feels like choosing. A scientist creates a person in a laboratory, designs their brain molecule by molecule, programs their psychology precisely, installs specific beliefs, desires, values, personality traits, and then releases this person into the world, and the person deliberates about what to do, weighs options, considers consequences, makes decisions based on their reasons, their desires, their values, and all of this psychological processing feels normal from the inside, feels like genuine deliberation, genuine choice, and yet the person's entire psychology was determined by the scientist, was programmed. And so the person's choices are not really their own, not really free. Are the scientist's choices implemented through the person's brain? And the person is not responsible for actions that flow from programmed psychology, is more like a puppet than an agent. And this is the manipulation argument against compatibilism. The argument that being determined by natural causes, by genes and environment, is relevantly similar to being determined by manipulation, by programming. And if programmed persons lack free will, then naturally determined persons also lack free will. And since determinism says all persons are naturally determined, all persons lack free will if determinism is true, and compatibilism is false. And this manipulation argument, developed by Dirk Peerboom and others, creates a serious challenge for compatibilist theories, forces compatibilists to explain how natural determination differs from manipulation, how being caused by evolution and upbringing differs from being caused by a neuroscientist. And the argument remains controversial, remains debated, and compatibilists offer various responses. But the challenge persists. Imagine the manipulated person situation. They wake up in the laboratory, memories implanted, personality formed, and they go about their life, make choices, pursue goals, and from their perspective, everything seems normal. They feel like they are choosing freely, feel like their decisions are their own, and yet every thought, every desire, every value was installed by the scientist. And nothing about their psychology is random. Nothing escaped the scientist's control. And now consider whether this person is morally responsible for their actions, whether they deserve praise or blame. And the intuition is no. They are not responsible because their actions flow from programmed psychology, from values and desires they did not choose, that were imposed on them. And responsibility requires that psychology be one's own, not be externally determined. And the manipulated person's psychology is not their own, is the scientist's creation. And so they lack responsibility, lack free will. The manipulation argument proceeds through cases, starts with extreme manipulation, obvious programming, and then gradually moves toward more natural cases, and asks at each stage whether the person is responsible, and the cases are designed to show that there is no relevant difference between manipulation and natural causation, that if manipulation undermines responsibility, then natural determination also undermines responsibility. And the four-case argument, Peerboom's version, goes as follows. In case 1, a person is directly manipulated by scientists who induce specific mental states. In case 2, a person is programmed from birth by scientists who arrange their environment and training. In case 3, a person is determined by their genetic, inheritance, and upbringing without any intentional manipulation. In case 4, a person is determined by the normal causal processes of a deterministic universe. And Peerboom argues that there is no morally relevant difference between these cases, that if case 1 undermines responsibility, then so do the others. And since case 4 is just determinism, determinism undermines responsibility, and compatibilism is false. Visualize the progression, from direct neural manipulation to genetic engineering to natural upbringing to deterministic causation. And at each stage, the person's psychology is caused by factors beyond their control, factors they did not choose. And the manipulation argument says that the source of causation, whether intentional or natural, does not matter for responsibility. What matters is that the person's psychology was determined by factors beyond their control, and this determination undermines freedom regardless of whether a scientist or nature did the determining. And if we agree that the manipulated person, in case one is not responsible, then we must agree that naturally determined persons, in case 4 are also not responsible, and compatibilism, which says determinism is compatible with responsibility, is refuted. Compatibilists respond to the manipulation argument with various strategies. One response distinguishes between manipulation and natural determination, argues that manipulation involves bypassing the person's normal, deliberative processes, involves imposing psychology externally, while natural determination involves the person's psychology developing through normal processes, through learning and experience and interaction with the world. And this difference matters for responsibility, makes naturally determined persons responsible, even though manipulated persons are not. And the manipulation argument fails because it ignores this difference, treats all determination as equivalent when it is not. Another compatibilist response argues that the manipulated person is responsible, challenges the intuition that manipulation undermines responsibility, and this response requires biting the bullet, accepting that even persons whose psychology was programmed by scientists are responsible as long as their actions flow from their own deliberation, their own reasons, even if those reasons were installed. And this response preserves compatibilism by denying that manipulation undermines responsibility, by insisting that what matters for responsibility is not the origin of psychology, but its current functional organization. And if the person deliberates and acts on their deliberations, then they are responsible, regardless of how their psychology came to be. A third compatibilist response distinguishes between historical and structural accounts of responsibility, argues that responsibility depends on the structure of the person's psychology, on whether they have the right kind of control mechanisms, the right kind of reflective capacities, not on the history of how that psychology was formed and manipulated. Persons can have the right structure, even if their history is abnormal, and so they are responsible. And the manipulation argument fails because it assumes that history matters when only structure matters, and compatibilism is preserved by adopting a structural rather than historical account of responsibility. Incompatibilists defend the manipulation argument, defend the intuition that manipulation undermines responsibility, and argue that compatibilist responses are ad hoc, are motivated by a desire to save compatibilism rather than by principled distinctions, and there is no relevant difference between being determined by a scientist and being determined by genes and environment. Both involve the person's psychology being shaped by factors beyond their control. Both undermine the kind of control required for responsibility, and the manipulation argument succeeds in showing that compatibilism is false, that determination, whether by manipulation or by nature, is inconsistent with freedom. The manipulation argument also raises questions about what responsibility requires, about whether responsibility is historical, depends on how psychology was formed, or structural, depends only on current organization. And this debate is central to understanding free will, to clarifying what kind of control is required for moral responsibility. And the manipulation argument forces this debate into the open, makes it explicit. And even if the argument does not definitively refute compatibilism, it succeeds in challenging compatibilists to articulate their view clearly, to explain what distinguishes responsible from non-responsible agents. The programmed person walks through life, choosing, deliberating, acting, and feeling free. And the question remains whether they are genuinely responsible, whether their choices are truly their own, or whether they are puppets, implementations of the scientist's design, and the manipulation argument uses this person to challenge compatibilism, to question whether natural determination is really different from artificial manipulation, and the argument persists as one of the most powerful challenges to compatibilist theories. A challenge that highlights the difference between feeling free and being free, between subjective experience of choice and objective reality of determination, and the manipulated person remains choosing but programmed, free-feeling but determined, and whether such a person is responsible remains contested, and the manipulation argument endures as a permanent challenge to compatibilism, forcing recognition that if determinism is true, then we are all in a sense manipulated, determined by factors beyond our control, and whether this determination undermines responsibility, whether it makes us unfree, remains one of the deepest questions in philosophy of free will. The liar paradox. There exists a statement so simple that it collapses the foundations of truth itself, a sentence that devours its own meaning the moment it is spoken. And this is the liar paradox, a loop that has haunted logicians and philosophers for over 2,000 years. The paradox is most famously expressed in a single declaration: this statement is false, and the mind recoils at what follows. For if the statement is true, then it must be false as it claims. But if it is false, then it must be true because it correctly identifies itself as false. And so the cycle begins again, spiraling endlessly, without resolution, without escape. The ancient Greeks were the first to wrestle with this demon of language, and Epimenides, the Cretan, is often credited with an early version when he declared that all Cretans are liars, which implies that if he himself is a Cretan, then his statement must be a lie, which means Cretans might actually tell the truth, which means his statement might be true, which means it is false again, and the contradiction churns without mercy. Philosophers have spent centuries trying to solve or dissolve the paradox, and some argue that self-referential statements like this are simply meaningless, that language breaks down when it tries to refer to itself in this way, while others suggest that truth is not binary but exists on a spectrum, allowing for statements that are neither fully true nor fully false, hovering in some undefined space between. Bertrand Russell encountered similar contradictions when developing set theory and discovered that self-reference could destroy the entire logical framework of mathematics, leading him to create new systems that carefully excluded paradoxes like the liar from ever forming. The paradox also influenced Kurt Gödel, whose incompleteness theorems proved that within any sufficiently complex logical system, there will always be true statements that cannot be proven, which itself echoes the spirit of the liar paradox, the idea that truth and provability are not always the same thing. Some modern logicians have proposed paraconsistent logics, systems where contradictions can exist without causing the entire structure to collapse, allowing the liar paradox to be true and false simultaneously without forcing us to accept that everything is true, which would render logic useless. Others reject the paradox entirely, claiming that natural language is too vague and imprecise to support rigorous logical analysis, that the liar paradox is a quirk of grammar rather than a deep philosophical problem. Yet the paradox persists, refusing to die, surfacing in new forms across disciplines, from computer science to legal theory, anywhere that self-reference appears. Consider a sign that reads, "Ignore this sign," or a rule that states there are no rules, or a person who says everything I say is a lie, and the same strange loop emerges, the same dizzying collapse of meaning. The liar paradox forces confrontation with the limits of language, logic, and truth itself, suggesting that reality may not always fit neatly into categories of true and false, that some truths may be inherently unstable, slipping through the fingers the moment they're grasped. It reminds us that words are not perfect mirrors of reality, but tools shaped by human thought. And sometimes those tools turn on themselves, revealing cracks in the structures we build to make sense of existence. The fat man, variant, when pushing someone off a bridge, becomes murder. The runaway trolley races toward 5 people bound to the tracks. The same setup as before, but now there is no lever, no switch to pull, no way to divert the trolley onto another track. And you stand on a footbridge directly above the tracks, watching the trolley approach. And next to you stands a very large person, large enough and heavy enough that if they fell onto the tracks, their body would stop the trolley, would derail it or bring it to a halt, saving the 5 people below, but killing the large person instantly. And you could push this person, could place your hands on their back and shove them over the railing, and they would fall, and the trolley would stop, and 5 lives would be saved at the cost of 1. And the numbers are identical to the original trolley problem, 5 saved and 1 killed, but the method is different. And this difference makes most people recoil, makes them say, no, I would not push, even though the consequence is the same as pulling the lever in the original case. And this asymmetry is the heart of the fat man variant, sometimes called the footbridge problem, a thought experiment that probes our moral intuitions about direct versus indirect harm, about using people as means versus affecting them as side effects, and about the limits of consequentialist reasoning. Imagine yourself on the bridge, the large person standing peacefully beside you, unaware of the danger below, and you know that pushing them will save 5 lives. The calculus is clear, 1 death versus 5 deaths, and if outcomes are all that matter, then pushing is required, is morally obligatory, is the obviously right choice. But your hands hesitate, your body resists, because pushing feels like murder, feels like killing, feels fundamentally wrong in a way that pulling a lever does not. And this feeling, this visceral moral reaction, reveals something about how we think about ethics, reveals that we distinguish between different ways of bringing about the same result, that the means matter, not just the ends, that how we save lives affects whether saving them is permissible. The distinction centers on intentionality and instrumentalization. In the original lever case pulling, the lever diverts the trolley, and the 1 person on the side track dies as an unfortunate consequence. Their death is foreseen, but not intended. You are not trying to kill them. You are trying to redirect the trolley, and their presence on the track is almost incidental. If they were not there, the trolley would still be diverted and the 5 would still be saved, whereas in the fat man case, pushing the person is specifically intended to use their body as an obstruction. Their death is not a side effect, but the means by which the trolley is stopped. You are deliberately killing them to achieve your goal, and if by some miracle they survived the fall, the trolley would not be stopped and the 5 would not be saved. Their death is essential to your plan, is what you're aiming at. And this makes the act feel more like murder, more like treating a human being as a mere object, as a tool to be used and discarded. Kantian ethics formalizes this intuition through the principle that persons are ends in themselves and should never be treated merely as means. And pushing the large person treats them as a mere means, uses their body without their consent to achieve a goal, reduces them to an instrument. Whereas pulling the lever does not treat the 1 person on the side track as a means. They are harmed as a side effect, but not used, not instrumentalized. And this distinction, Kantians argue, is morally crucial, marks the line between permissible and impermissible killing. And the fat man variant falls on the wrong side, is impermissible because it uses a person, violates their dignity, treats them as less than fully human. Consequentialists reject this reasoning, argue that the distinction between intended and foreseen harm is morally irrelevant, that what matters is the result. 5 lives saved and 1 life lost. And whether the 1 person is killed as a means or as a side effect makes no difference to the outcome, makes no difference to the people involved. The large person dies either way. The 5 people are saved either way, and refusing to push means accepting 5 deaths to avoid 1, means valuing squeamishness or abstract principles over actual lives. And this seems absurd, seems like letting moral theory override common sense. And consequentialists argue that in extreme cases, in genuine life or death dilemmas, the right action is the one that minimizes harm, maximizes welfare, saves the most lives, and any principle that forbids this is flawed, is giving too much weight to feelings and not enough to results. Visualize the large person standing on the bridge. They have thoughts, feelings, plans, loved ones, a life with value and meaning, and you're contemplating ending that life, snuffing it out. Not in self-defense, not as punishment, but as a tool to save others. And this feels different from pulling a lever. It feels more intimate, more violent, more like hands-on killing, and psychological research confirms this. People report stronger emotional reactions to the footbridge scenario, stronger activation of brain regions associated with personal moral judgment, and this emotional response is not irrational or mere squeamishness, but reflects deep moral intuitions about personal agency, about the wrongness of directly causing harm to an individual, about the sanctity of bodily autonomy. The fat man variant also raises questions about consent and voluntariness, because the large person has not volunteered to be sacrificed, has not consented to being used as a trolley stopper, and using their body without permission violates autonomy, violates the principle that competent adults have the right to control what happens to their own bodies. And this is true even if using them would save lives, even if the overall outcome would be better, because respecting autonomy means allowing people to refuse to help. Even when helping would be beneficial, means recognizing that people are not resources to be allocated for the greater good, but individuals with rights, with the right to say no, with the right not to be sacrificed against their will. Some philosophers have proposed intermediate cases to test the boundaries. Suppose the large person is standing on a trapdoor that you could open remotely, dropping them onto the tracks without physically touching them. Is this more like the lever case or more like the pushing case? Or suppose the large person is terminally ill and unconscious. Does this change the moral calculus? Does it make using them more permissible? Or suppose they have explicitly consented in advance to being used in such situations? Does consent eliminate the moral problem? And these variations probe the principles at stake, try to isolate what exactly makes the pushing wrong, whether it is the direct causation, the physical contact, the lack of consent, the instrumentalization, or some combination. And different moral theories give different answers, diagnose the wrongness differently, and the variant becomes a tool for testing ethical theories, for exposing their commitments and seeing where they lead. The footbridge stands above the tracks. The large person breathes beside you unaware. The trolley approaches and the 5 people below are oblivious to their doom. And you must decide, push or do not push, kill or let die, violate one person's rights, or allow 5 people to perish. And there is no time for lengthy deliberation, no time to consult ethicists or calculate utilities. Only a choice that will haunt you regardless. Because pushing means you killed someone, placed your hands on them, and ended their life. And not pushing means 5 people died who could have been saved. And either way, the weight is crushing. The responsibility immense, and the fat man variant offers no comfort, no resolution, only the stark presentation of a choice that reveals the limits of moral theory, the inadequacy of simple principles, the irreducible difficulty of cases where values conflict, where any action involves loss, and the problem remains. A thought experiment that disturbs, that challenges, that refuses to yield easy answers, and that reminds us that morality is not a puzzle with solutions, but a practice requiring wisdom, courage, and the willingness to live with choices that are never fully justified, never free of doubt, never untainted by the recognition that whatever we do, someone suffers, and we are responsible. The frozen time paradox. Time flows, or so it seems, carrying events from past to present to future in an unbroken stream. Yet what if time could stop? What if every process in the universe froze for a moment, or an hour, or 1,000 years, and then resumed exactly as it was? Would anyone notice? Could anyone notice? And this is the frozen time paradox, a thought experiment that questions whether time itself is observable, or whether it is merely an ordering of events, invisible and perhaps illusory. Imagine that at this very moment, time stops. Every atom ceases to move, every thought halts mid-formation, every photon hangs suspended in space, the entire universe frozen in a perfect still image. And this frozen state persists for an arbitrary duration, perhaps 1 billion years, and then suddenly time resumes, and everything continues exactly as it was. And the question arises, did anything happen during that frozen interval? Did time pass? And if no change occurred, can it be said that any time elapsed at all? The paradox strikes at the relationship between time and change, suggesting that time without change is meaningless or undetectable, that the passage of time is defined by the occurrence of events, and that if nothing changes, then nothing distinguishes one moment from another, and so the frozen interval, no matter how long, is equivalent to no interval at all. Aristotle grappled with this issue, arguing that time is the measure of change, that time does not exist independently of the processes it measures, and that without motion or change there can be no time. And this view suggests that the frozen time scenario is not a case of time continuing without change, but rather a case of time ceasing to exist during the frozen period. Others, particularly those who embrace the block universe view, argue that time is an independent dimension of space-time, that it exists whether or not anything changes within it, that the frozen interval would be a real extension of time, even if no events occurred within it. Though this raises the question of how such an interval could ever be detected or have any physical meaning. The paradox also touches on the nature of consciousness and subjective experience, because if time froze and then resumed, no conscious being would remember the frozen period, no measurement device would register it, no physical process would show evidence that it occurred, and so in what sense did it happen? And if it leaves no trace, can it be said to have any reality at all? Some philosophers draw a distinction between time as a parameter in physical equations, a variable that describes when things happen, and time as it is experienced, the feeling of duration and flow. And they suggest that the frozen time paradox exposes a gap between these two concepts, that mathematical time might continue during a frozen interval, but experiential time would not. The paradox connects to debates about the reality of time, whether time is fundamental or emergent, whether it is a feature of the universe or a feature of how we perceive the universe, and whether the flow of time, the sense that the present moment is moving forward, is an objective fact or a subjective illusion created by consciousness. Quantum mechanics adds another layer to the puzzle, because at the quantum level, the concept of time becomes strange. Entangled states do not evolve smoothly, but exist in superposition until measured, and some interpretations suggest that time emerges from quantum correlations rather than being a fundamental aspect of reality. The frozen time paradox forces confrontation with the question of what time is, whether it is possible for time to exist without change, whether duration has meaning in the absence of events, and whether the universe could be paused and unpaused without anyone ever knowing, without any physical consequence, and if such a scenario is indistinguishable from time continuing normally, then perhaps the question itself is meaningless, a pseudo-problem that arises from thinking about time as if it were a substance that flows rather than a dimension that orders. And yet the intuition remains that time is real, that it passes, that moments follow one another, and the paradox lingers as a reminder that even this most basic aspect of existence, the passage of time, is far from fully understood. The Fermi paradox. Where is everybody in this crowded universe? The Milky Way galaxy contains hundreds of billions of stars, many with planets, and our galaxy is one of hundreds of billions of galaxies in the observable universe. And Earth formed about 4.5 billion years ago, relatively late in cosmic history, and life emerged within 1 billion years, and intelligence and technology developed recently. And these facts suggest that Earth is not special, that the conditions that led to life here should occur elsewhere, And if even a tiny fraction of planets develop intelligent civilizations, and if even a small percentage of those civilizations develop technology capable of space travel or interstellar communication, then the galaxy should be teeming with evidence of alien intelligence. We should see their radio signals, their spacecraft, their structures, their influence on stars and planets, and yet we see nothing, hear nothing, find no evidence of extraterrestrial intelligence despite decades of searching, despite scanning the skies with radio telescopes, despite analysing thousands of exoplanets. And this silence, this absence of evidence, is the Fermi paradox, named after physicist Enrico Fermi, who reportedly asked during a lunch conversation in 1950, "Where is everybody?" And this question, simple and childlike, conceals one of the deepest puzzles in science, the question of whether we are alone in the universe, or whether alien civilizations exist but remain undetected for reasons we do not yet understand. The paradox can be stated more precisely through the Drake equation, an attempt to estimate the number of communicating civilizations in our galaxy. The equation multiplies together several factors: the rate of star formation, the fraction of stars with planets, the number of habitable planets per star system, the fraction of habitable planets where life emerges, the fraction of life-bearing planets where intelligence evolves, the fraction of intelligent species that develop technology, and the lifetime of technological civilizations. And depending on the values assigned to these factors, the equation predicts anywhere from 0 civilizations besides us to millions, and optimistic estimates suggest thousands or millions of alien civilizations should exist in our galaxy alone. And over billions of years, some of these civilizations should have spread through the galaxy, colonizing stars, building structures, leaving traces, and yet we see nothing. And this gap between expectation and observation is the Fermi paradox. Various explanations have been proposed, grouped into several categories. One possibility is that intelligent life is extraordinarily rare, that one or more factors in the Drake equation is much smaller than optimistic estimates suggest. Perhaps the emergence of life is a rare event. Perhaps the evolution of complex multicellular organisms requires unlikely coincidences. Perhaps intelligence is not an inevitable outcome of evolution, but a fluke that happened once on Earth and nowhere else. And if intelligence is sufficiently rare, then perhaps we are the first or among the first civilizations in the galaxy, and the silence is explained by our being early arrivals, alone for now, but perhaps not forever. Another category of explanations invokes the Great Filter, a hypothetical barrier that prevents civilizations from reaching the stage where they are detectable across interstellar distances. And the filter could be in our past, something that makes the emergence of intelligence extremely difficult, in which case humanity has passed the filter and the future is open, or the filter could be in our future, a challenge that civilizations face and almost always fail. Perhaps self-destruction through war or environmental collapse, perhaps technological stagnation, perhaps a transition that seems likely but proves fatal. And if the great filter lies ahead, then our survival is not guaranteed, and the silence of the cosmos is ominous, a warning that intelligence tends toward extinction. A third category suggests that civilizations exist but remain undetected for various reasons. Perhaps they communicate using technologies we have not discovered. Perhaps they deliberately hide to avoid contact with younger civilizations. Perhaps they exist in forms we would not recognize as life or intelligence. Perhaps they transcend physical form and migrate into cyberspace or other dimensions. Or perhaps the distances and timescales involved are so vast that civilizations exist but are separated by millions of light years and billions of years, arising and falling in isolation, never overlapping in space and time, and so contact is impossible. Not because civilizations do not exist, but because the universe is too big and time is too long. Visualize the galaxy as a vast ocean, and civilizations as islands, separated by light years of empty space. and each island has a brief window of technological activity, a few thousand years perhaps, before collapse or transformation, and the ocean is so large and the windows so brief that the probability of two civilizations existing simultaneously within communication range is vanishingly small. And so each civilization looks out, sees emptiness, hears silence, and concludes it is alone. And yet across the galaxy and across time many such civilizations exist, but they never meet, never communicate, never know each other, and the Fermi paradox is resolved not by the absence of life, but by the impossibility of contact. Another explanation, more speculative, suggests that we are living in a simulation, that the observable universe is a computational construct created by an advanced civilization and the silence is programmed. No other civilizations are simulated because the creators are interested only in studying us, or because simulating multiple civilizations is too computationally expensive. And this explanation, while unfalsifiable, is logically possible and provides a clean resolution to the paradox, though it raises new questions about the nature of the simulators and their purposes. The Fermi paradox has practical implications for the search for extraterrestrial intelligence, for SETI programs that scan the skies for radio signals, for astrobiology missions that search for life on Mars or the moons of Jupiter and Saturn, and for the question of whether humanity should attempt to contact alien civilizations or remain silent. Because if the great filter lies ahead, if civilizations typically self-destruct or face existential dangers, then advertising our presence might be risky, might attract attention from hostile or indifferent intelligences, and the silence of the cosmos might be a survival strategy, a lesson learned by civilizations that survive, and if so, then broadcasting our existence might be foolish, might mark us for extinction or exploitation. The paradox also touches on philosophy and the meaning of human existence, because if we are alone, if no other intelligence exists anywhere in the observable universe, then humanity carries a unique responsibility. We are the universe's only way of understanding itself, the only conscious observers, the only beings capable of science and art and love, and the future of consciousness depends on us, on whether we survive and spread. And this realization, far from being comforting, is terrifying, because it places an enormous burden on a species that has barely begun to leave its home planet. And if we fail, if we destroy ourselves, the universe returns to darkness, to unconsciousness, to a vast emptiness where stars burn and galaxies collide. But no one watches, no one cares, no one knows. The stars shine silent and distant, and we listen, and we hear nothing, and the silence stretches across billions of light years, across billions of years, and Fermi's question echoes, where is everybody? Where are the aliens? Where are the civilizations that should exist, that must exist, that the numbers say should exist, and the answer does not come? And the paradox remains unresolved, pressing, urgent, a question that haunts astronomers and philosophers, a mystery that drives the search for life beyond Earth, and a reminder that despite all our knowledge, despite all our telescopes and equations, we do not know whether we are alone or whether the universe teems with life. And the silence, profound and unbroken, waits, and we wonder and we search, and the paradox persists. The free rider problem, why nobody pays for what everyone wants. A community needs a public good, needs streetlights perhaps, or clean air or national defence, and this good has a special property. It is non-excludable. Once provided, it is available to everyone, regardless of whether they contributed to its provision, and it is non-rivalrous. One person's use does not reduce availability for others. And these properties create a problem, create incentives for free riding, for enjoying the benefits without bearing the costs, and each individual reasons that their contribution is small, is negligible, will not determine whether the good is provided, and so they can free ride, can enjoy the streetlights, whether they pay or not. And since paying is costly and the good will be provided or not, regardless of their individual contribution, it is individually rational to free ride. And if everyone reasons this way, then no one contributes. The good is not provided, and everyone is worse off than if everyone had contributed. And this is the free rider problem, a fundamental challenge in public economics, a demonstration that voluntary provision of public goods is difficult, tends toward under-provision, and solving the problem requires mechanisms that make contribution individually rational, requires collective action, requires institutions that enable groups to provide goods that individuals cannot or will not provide voluntarily. And the free rider problem explains why governments exist, why taxation is necessary, why voluntary charity is insufficient for providing public goods. And the problem remains central to political philosophy, to debates about the role of government, to questions about when collective coercion is justified. Imagine a neighborhood deciding whether to install streetlights, and the lights would benefit everyone, would make the streets safer, would be valued by all residents. And suppose the lights cost $100 per household, and each household values the lights at $150. So collectively, the benefit exceeds the cost. Provision is efficient, but each household faces a decision, contribute or free ride. And the calculation is straightforward. If enough others contribute, the lights will be installed regardless of whether I contribute. And if I contribute, I pay $100 and get $150 of benefit for net benefits of $50. But if I free ride, I pay nothing and still get $150 of benefit for net benefits of $150. So I am better off free riding, and if not enough others contribute, then the lights will not be installed regardless of whether I contribute. And if I contribute, I pay $100 and get nothing because the lights are not installed. And if I free ride, I pay nothing and get nothing. So I am no worse off free riding, and in both cases, free riding dominates contributing. And since every household reasons this way, no one contributes, the lights are not installed, and everyone loses the net benefit they could have had. And this is the free rider problem. The free rider problem demonstrates that individual rationality can lead to collective inefficiency, that goods which everyone wants can fail to be provided because no individual has incentive to contribute, and the problem is structural, is inherent in the properties of public goods, and cannot be solved by appealing to altruism or social responsibility, because even small amounts of altruism are insufficient, because as long as some people free ride, the burden on contributors increases, and this creates resentment, undermines cooperation, and voluntary provision tends to fail. And the solution typically involves coercion, involves mandatory contributions through taxation, and governments exist partly to solve free rider problems, to provide public goods through collective funding, and taxation is justified on the grounds that it enables provision of goods that voluntary contribution cannot reliably provide. Visualize the free rider problem as a threshold public good, where the good is provided only if total contributions exceed some threshold, and individuals must decide whether to contribute without knowing whether others will contribute, and the dominant strategy is to free ride because your contribution is costly and makes little difference to whether the threshold is met, and everyone free rides. The threshold is not met. The good is not provided, and this shows why voluntary provision fails, why collective action problems arise, why coordination on contribution is difficult without institutional mechanisms. And solving the problem requires commitment devices, requires mechanisms that ensure contributions are made, that prevent free riding, and taxation is one such mechanism, makes contribution mandatory, eliminates the free riding option, and enables provision of public goods that markets fail to provide. One response to the free rider problem is Lindahl taxation, a theoretical solution where each individual pays according to their marginal benefit from the public good, pays their willingness to pay, and this makes contribution individually rational because you pay only what the good is worth to you. But Lindahl taxation faces practical problems, requires knowing each person's valuation, which people have incentive to misrepresent, have incentive to understate to reduce their tax burden. And the mechanism is not incentive compatible, is vulnerable to strategic behaviour, and cannot be implemented in practice. And so while Lindahl taxation is theoretically optimal, it does not solve the real-world free rider problem. Another response is assurance contracts, where contributions are collected conditionally, are returned if the threshold is not met. And this solves one problem with voluntary provision, eliminates the risk of contributing without the good being provided. But assurance contracts do not eliminate free riding incentive, do not make contributing dominant, because you still benefit from the good whether you contribute or not. And so assurance contracts help but do not fully solve the problem. And empirical evidence shows that contribution rates improve with assurance contracts but remain below optimal levels. A third response is social sanctions, where free riders are punished through social disapproval, through reputation loss, through exclusion from other cooperative activities, and social sanctions can support contribution in small groups where behaviour is observable, where reputation matters, where repeated interaction creates incentives for cooperation, and community provision of public goods often relies on social sanctions, relies on norms that support contribution and punish free riding. And these mechanisms can be effective in tight-knit communities but are less effective in large anonymous societies where behaviour is hard to observe and reputation effects are weak. The free rider problem also appears in debates about international cooperation, about providing global public goods like climate stability, pandemic prevention, biodiversity preservation, and these goods are non-excludable and non-rivalrous at global scale, and nations face free rider incentives, benefit from the good whether they contribute or not. And this makes international cooperation difficult, makes agreements fragile, and nations have incentive to free ride, to benefit from others' contributions while minimizing their own. And solving global free rider problems requires international institutions, requires mechanisms for monitoring and enforcement, requires ways to make contribution individually rational for nations. And the difficulty of achieving such cooperation explains why global public goods are underprovided, why climate change proceeds despite universal acknowledgement of its dangers, why pandemic preparedness is inadequate despite obvious benefits. The problem also raises philosophical questions about political obligation, about whether citizens have duties to support public goods, whether taxation is legitimate coercion or justified contribution, and libertarians argue that taxation for public goods is problematic, violates individual rights, and anarcho-capitalists argue that even genuine public goods should be provided voluntarily or not at all, while social democrats argue that taxation is justified to solve collective action problems, is necessary for provision of goods that voluntary mechanisms cannot reliably provide, and the debate turns on whether the free rider problem justifies coercion, whether preventing free riding is sufficient reason to impose mandatory contributions, and different political philosophies answer differently. Some argue that the free rider problem is overstated, that voluntary provision is more successful than theory predicts, that people do contribute to public goods despite free rider incentives. And empirical evidence supports this, shows that people do contribute voluntarily to charities, to public radio, to open source software, and contribution rates exceed zero even when free riding is possible. And this suggests that people are not purely self-interested, have preferences for fairness, for contributing to collective goods, for avoiding being seen as free riders, and behavioral economics explains these patterns through social preferences, through conditional cooperation, through warm glow effects from giving, and while voluntary provision remains below optimal levels, it is not zero. And this shows that humans are more cooperative than pure economic theory predicts. But it does not eliminate the free rider problem, does not make voluntary provision reliably sufficient, and government provision remains necessary for most public goods. The streetlights remain dark, the clean air remains polluted, the defence remains unprovided, and everyone wishes for the public good, but no one contributes. Everyone free rides, everyone waits for others to pay, and the good is not provided, and the free rider problem persists as one of the fundamental challenges in political economy, remains a justification for government, remains a reason why taxation exists, why collective provision is necessary, and the problem shows that markets fail for public goods, that voluntary mechanisms are insufficient, that individual rationality leads to collective inefficiency, and solving the problem requires institutions, requires mechanisms that make contribution mandatory or that change incentives to make contribution rational, and without such mechanisms, public goods are underprovided. Remain goods that everyone wants but nobody provides, and the free rider problem endures. The ladder paradox: how moving objects shrink and fit where they shouldn't. A ladder 10 meters long rushes toward a garage that is only 8 meters deep. The garage has a front door and a back door, both initially open, and the ladder is traveling at a significant fraction of the speed of light, fast enough that length contraction becomes important. And according to special relativity objects moving at high speed contract along their direction of motion, and an observer standing in the garage watching the ladder approach calculates that at 80% of light speed, the ladder contracts to 6 meters, shorter than the garage, and so the observer plans to trap the ladder inside by simultaneously closing both doors for a brief moment, catching the entire contracted ladder inside the 8-meter garage. And this seems straightforward. The moving ladder fits because it is contracted, but now consider the perspective of someone riding on the ladder. In their reference frame, the ladder is at rest and maintains its full 10-meter length, while the garage is moving toward them at 80% of light speed, and so the garage contracts to less than 5 meters deep, far too small to contain the 10-meter ladder, and the person on the ladder knows that the front of the ladder will exit the back door before the back of the ladder enters the front door, and trapping the ladder inside is impossible, and so the two observers disagree about whether the ladder fits inside the garage, whether both doors can be closed simultaneously with the ladder inside. And this is the ladder paradox, also called the barn pole paradox, a puzzle about how length contraction and simultaneity interact in special relativity. The resolution lies in understanding that simultaneity is relative, that events which are simultaneous in one reference frame are not simultaneous in another, and the garage observer sees both doors closing at the same time, trapping the ladder, but the ladder observer sees the doors closing at different times. The front door closes first, then the back door closes later, and in the ladder frame, the sequence of events is as follows. The front of the ladder, still 10 meters away from the back of the ladder, enters the contracted garage and immediately exits the back door, and only after the entire ladder has passed through the garage does the back door close, followed by the front door closing, and so in the ladder frame, the ladder never fits entirely inside the garage. It is always longer than the garage, but the doors are never closed simultaneously with the ladder inside, and this removes the contradiction. Both observers agree on the physical facts. They agree on when collisions occur, on whether the ladder gets scratched or damaged, but they disagree about which events are simultaneous, about the order in which certain events happen, and this disagreement is not a matter of illusion or observation delay, but a fundamental feature of space-time in special relativity. Imagine space-time diagrams for both perspectives. In the garage frame, the diagram shows the two doors as vertical lines fixed in position, and the ladder as a diagonal streak moving horizontally through space and vertically through time, and the ladder is shortened by length contraction, and there is a moment when the back of the ladder has entered the front door and the front of the ladder has not yet exited the back door, and at this moment both doors can be closed simultaneously, trapping the contracted ladder, and in the ladder frame the diagram shows the ladder as two vertical lines, the front and back of the ladder stationary, and the garage as a moving object, contracted along the direction of motion, and the two doors close at different times. First, the front door closes and then opens, allowing the front of the ladder to pass, and then the back door closes after the back of the ladder has already entered, and the doors are never simultaneously closed around the ladder, and both descriptions are correct. Both are consistent with the laws of physics, and the apparent contradiction arises only from expecting that simultaneous in one frame means simultaneous in all frames, and relativity denies this. Simultaneity is frame dependent. The paradox also highlights the role of signals and information, because if the closing of the doors is controlled by signals sent at the speed of light, then the relativity of simultaneity ensures that the signals arrive at different times in different frames, and the physical mechanism that closes the doors respects causality and relativity, and no contradiction arises. The doors can be set to close when the ladder is inside, as measured in the garage frame, and this same mechanism, viewed from the ladder frame, closes the doors at different times, and the ladder is never trapped because it never fits entirely inside, and both descriptions are correct and consistent. Some people find this resolution unsatisfying. It seems like the ladder either fits or does not fit. There should be an objective fact of the matter, but relativity says that fits inside is not an objective notion. When motion is involved, it depends on what simultaneity convention is used, on which reference frame is chosen, and different frames can disagree about spatial relationships without any frame being wrong. And this is one of the deepest lessons of relativity, that spatial and temporal relationships are frame dependent, that there is no absolute space or absolute time, and that what counts as simultaneous or as fitting inside depends on the observer's state of motion. The ladder paradox has practical analogues in particle physics, where particles travelling at relativistic speeds appear contracted in the laboratory frame, and this contraction affects how they interact with detectors, how they traverse magnetic fields, and how their collisions are modelled, and physicists routinely account for length contraction and time dilation in analysing experiments. And the paradoxical features of relativity are not mere thought experiments, but daily realities in accelerator laboratories. Visualise the ladder streaking toward the garage, its atoms compressed along the direction of motion, the electromagnetic forces between atoms adjusted by the motion, creating a physically shorter object in the garage frame, and the garage rushing toward the ladder in the ladder frame, compressed to a narrow slit, and the ladder threading through this slit without ever being contained. And both pictures are correct, both are consistent, and the paradox dissolves once simultaneity is properly understood, once it is accepted that different observers experience different orderings of spatially separated events, and the ladder paradox remains a teaching tool, an illustration of how length contraction and relativity of simultaneity work together, how apparent contradictions in relativity are resolved by careful analysis of reference frames, and how our intuitions about space and time, trained on low-speed everyday experience, fail completely when speeds approach that of light, and the ladder passes through. Contracted or not, trapped or not, depending on who you ask, depending on what frame you occupy, and the paradox endures as a reminder that space and time are not what they seem. That motion affects not just how we measure things, but what length and simultaneity mean, and that Einstein's revolution was not just about equations, but about reconceiving the very fabric of reality.